Hi everyone, welcome to ARA'S Maths tutorial. நம்மளோட previous ரெண்டு கிளாஸ்ல ரெண்டு eigen values eigen vectorsல ரெண்டு ப்ராப்ளம் பார்த்தோம். ஒவ்வொரு ப்ராப்ளத்துலயும் different cases பார்த்துட்டு வரோம். இது third problem. இந்த third problemல என்ன இருக்கும் அப்படின்னா இந்த values eigen values will be repeated eigen values இருக்கும். Similar equations occur ஆகும். So அதனால இந்த ப்ராப்ளம் இப்ப பார்க்க போறோம். See, find the eigenvalues and eigenvectors of the matrix A equal to 0, 1, 1, 1, 0, 1, 1, 1, 0. This is the given matrix. நமக்கு தெரியும் characteristic equation இந்த மாதிரி find out பண்ணலாம். Lambda cube minus C1 lambda square plus C2 lambda minus C3 equal to 0. Here C1 is sum of diagonal elements. Here diagonal elements are 0, 0, 0. So sum of diagonal elements will be 0 plus 0 plus 0 equal to 0. So C1 equal to 0. C2 sum of minors of diagonal elements. The diagonal element minor for the first element A11 is determinant of 0, 1, 1, 0, and for A22 determinant of 0, 1, 1, 0, and for A33 the minor is determinant of 0, 1, 1, 0. Okay. Now the determinant for this minor is 0 minus 1. Here 0 minus 1. Here also 0 minus 1. So the total will be minus 3. C2 value minus 3. And C3 is determinant of A. Determinant of the given matrix. Here 0 and determinant of 0, 1, 1, 0 minus 1 into determinant of 1, 1, 1, 0. And 0 plus 1 into determinant of 1, 0, 1, 1. Here 0 into 0 minus 1. Minus 1, 0, minus 1, plus 1 into 1 minus 0. So the final answer is C3 equal to 2. Now the characteristic equation is lambda cube minus C1 is 0. So next term C2. C2 is minus 3. So minus 3 into lambda and C3 is 2. So minus C3 is minus 2. So the characteristic equation is lambda cube minus 3 lambda minus 2 equal to 0. By synthetic division, we are going to find the roots of this equation. By trial and error, we are taking minus 1 here. Minus 1 எடுத்துட்டு நம்ம synthetic division போட்டோம் அப்படின்னா we will have lambda plus 1 into lambda square minus lambda minus 2 equal to 0. From this factor, lambda equal to minus 1. In this factor, the factorization will be lambda minus 2 into lambda plus 1 equal to 0. Because if you take minus 2 and 1 multiply பண்ணும்போது minus 2 வரும், add பண்ணும்போது minus 1 வரும். So factorization is lambda minus 2 into lambda plus 1 equal to 0. This implies lambda equal to 2 and lambda equal to minus 1. So the eigenvalues are minus 1, again minus 1 and 2. Next we are going to find the eigenvector. First let us take lambda. What is eigenvector? Eigenvector is a non-zero vector x satisfying the condition a minus lambda I into x equal to 0. What is a minus lambda I? The diagonal elements will be minus lambda. So minus lambda 1, 1, 1 minus lambda 1, 1, 1 minus lambda. A minus lambda I into x vector. Minus lambda 1, 1 into x1, x minus lambda 1, 1. 1 minus lambda 1, 1, 1 minus lambda, and the vector x vector is x1, x2, x3 column vector, that is equal to 0, 0, 0. Multiplying these two matrices, we will have minus lambda x1 plus x2 plus x3 equal to 0. Second equation is x1 minus lambda x2 plus x3 equal to 0. Third equation x1 plus x2 minus lambda x3 equal to 0. When lambda equal to minus 1. First we are taking lambda equal to minus 1. Putting lambda equal to minus 1, we will have minus of minus 1 will be plus 1. So plus x1 plus x2 plus x3 equal to 0. In second equation, x1 lambda value minus 1, so it will become plus x2 plus x3 equal to 0. Third equation is also x1 plus x2 plus x3 equal to 0. Here we have to treat all the three equations are similar equation. This is a different case. இந்த மூணு ஈக்குவேஷன் பாருங்க ஒரே மாதிரி இருக்கும். So we have to treat two variables as free variable. Free variables means நம்ம any two variable any two values assume பண்ணிக்கலாம். அந்த ரெண்டு வேல்யூ யூஸ் பண்ணி தேர்ட் வேல்யூவை நம்ம கால்குலேட் பண்ணணும். இங்கே நம்ம என்ன பண்றோம் அப்படின்னா நான் x1 0ன்னு எடுத்திருக்கேன், அப்புறம் x2 equal to 1ன்னு எடுத்திருக்கேன். Substituting these two values in this equation, we will have 0 plus 1 plus x3 equal to 0. From this, x3 equal to minus 1. So, the x1 value is 0, x2 value 1 and x3 equal to minus 1. Therefore, the eigenvector corresponding to lambda equal to minus 1 is x1 equal to 0, 1, minus 1. Again, we are having the eigenvalue lambda equal to minus 1. For this case, let us assume another two values for x1 and x2. Previously, நம்ம என்ன எடுத்திருக்கோம் அப்படின்னா x1 equal to 0, x2 equal to 1 எடுத்திருக்கோம். Here, I am assuming x1 equal to 1 and x2 equal to 0. Substituting these two values in this equation, 1 plus 0 plus x3 equal to 0. From this, x3 equal to minus 1. So, the corresponding eigenvector corresponding to lambda equal to minus 1 is x2 equal to 1, 0, minus 1. Next, let us take lambda equal to 2. Substituting lambda equal to 2 in these three equations, we will have minus 2x1 plus x2 plus x3 equal to 0. Second equation will become x1 minus 2x2 plus x3 equal to 0. Third equation, x1 plus x2 minus 2x3 equal to 0. Then by cross multiplication method, we are going to find the values of x1, x2 and x3. Okay. For x1, we have to start from the coefficients of x2. I am considering first two equations. So, the coefficients of x2 is 1 minus 2. Next 1, 1. Again minus 2, 1. And finally 1 minus 2. x1 divided by determinant of these two columns 1 1 minus 2 1. x2 divided by determinant of these two columns 1 minus 2 1 1. And for x3 determinant of minus 2 1 1 minus 2. The value of this determinant is 1 plus 2. Minus of minus 2 plus 2. Here 1 minus of minus 2 plus 2. 4 minus 1. Now x1 divided by 3, x2 divided by 3, x3 divided by 3. Therefore, the eigenvector corresponding to lambda equal to 2 is x3 equal to 3, 3, 3. It can be written as 1, 1, 1. So, the eigenvector corresponding to lambda equal to 2 is 1, 1, 1. That's all eigenvalues and eigenvectors. In our next video, let us see the problems on Taylor-Hamilton theorem. Thanks for your watching.